Good afternoon, fellow Patriots. What you see here is a 3D printer that I'm going to attempt to control using the VEX Cortex system, which includes the VEX Cortex microcontroller and a VEX Cortex game controller. As you well know, 3D printers are very popular these days for making all sorts of products at home. One of the motors that's actually missing from the VEX construction system is the stepper motor. And this motor is a very important type of motor used in industry for automation and for all sorts of control mechanisms, electromechanical control mechanisms. And it's also used in manufacturing and in assembling robots. The 3D printer shown in front of you is a Tronxy 3D printer. It actually functions very well as a 3D printer, but I'm also modifying it to be a 3D scanner system that I'm designing. This Tronxy 3D printer is a very good example of using stepper motors for automation and robotics. It uses various stepper motors to control the X, Y, and Z axis, as well as the extruders. Normally the Tronxy 3D printer is powered by the PSU that you see in back. But right now I'm going to use a 12-volt SLA battery instead for safety. I'm now going to power up the system and show you how it works. The first step is to power up the VEX Cortex and the game controller so that the VEX Cortex is ready to start controlling the system. The red board that you see in front of you is a RAMPS 1.4 3D stepper motor controller, which uses the TI DRV8825 stepper motor drivers. These drivers are very interesting since they can micro-step the steppers to up to 1/32 of a step, giving you incredible resolution. This is how 3D printers can get very, very accurate reproductions when 3D printing an object in plastic or nylon. You can see that I've wire wrapped connections between the RAMPS 1.4 stepper motor controller board and the VEX Cortex digital I/O ports. The wire wrap wire is a little bit more sturdy and does not pull out as easily, so it's safer to use for this type of application instead of using jumper wires or using the standard VEX wire control connectors. In order to do this, I used a block of pin headers that I plugged into the VEX Cortex digital I/O port. It's a 3-row connector which has one for the ground, one for the power, and one for the signal pin. Controlling a stepper motor using this board is relatively easy. You just pulse a step signal to make the motor move in either clockwise or counterclockwise direction, and you can pulse the direction line to change the direction to be clockwise or counterclockwise. So it only requires 2 digital I/Os per stepper motor. The power up sequence is to turn on the VEX Cortex first, which I've done, and then I'm going to turn on the power up the game controller. Now you can see the game controller powered up, all the lights are green, as well as the VEX Cortex with all its lights green. Right now I'm using a tethered mode with the USB male-to-male connector between the game controller and the VEX Cortex. The next step is to connect it to the battery, which is in back. I've now connected the 12-volt SLA battery to power the stepper motor controller board. This provides the necessary power to each stepper motor being driven. Currently I only have the Z-axis and the connected right now. Okay, everything's ready to go. So you're going to start seeing the Z-axis sliders moving up and down under control of the the VEX Cortex right here. And I'm just using two joystick axes right now to control it. And these are, right now, the stepper motors are moving at 1-step resolution, single step resolution, which is the lowest resolution mode. But it also is one of the fastest modes. Micro-stepping, I would have to send many more steps out to make these movements, or it'd move very slowly. Of course, it'd move more precisely. Moving slower would move more precisely, up to 1/32 of a step. In addition, I can move the X and Y axis on the top by connecting it to the board. I'm going to try doing that right now, and then you'll see some action on the top X and Y axis under control of the VEX Cortex game controller. Okay, here you see the moving. And this is all under control of the game controller. So I could even use it to draw pictures, do some sculpting, 3D sculpting, if I hooked up a Dremel tool to it, or a laser, use laser sculpting. And you could do this manually. You could create a paintbrush, draw artwork. And the advantage of doing it this way would be that you can actually train this XYZ robot, which is the 3D printer, to create your products. So you could create an initial painting or an initial sculpture, and then have it reproduce it automatically from then on by saving all the coordinates, the XYZ coordinates. Again, my application for this is a prototype 3D scanner, where these sliders are going to be used to slide and position the cameras at pre-programmed dwell sites during a 3D scan of objects. And that way, once I'm done scanning them in 3D, I can convert them to a COM file or a PLY file to be 3D printed later using the same printer. I have not damaged the printer. All I've done is just disconnected the wires from the its controller and plugged them into the RAMPS 1.4 controller, which is connected to the VEX Cortex. So again, this 3D printer is going to serve a dual purpose. It's going to be both a 3D printer and a 3D scanner when I'm done, if the 3D scanner works out. That's very experimental right now. That's what I'm designing at this point. But I'm showing you this to demonstrate what you can do with stepper motors and the VEX construction system, including the VEX Cortex microcontroller and the VEX game controller. The game controller can be used, like I said, to train it. So, for example, you could draw pictures, you could sculpt something and train it, and then have the robot reproduce that object later on using your creation, your initial creation. So that way you could sell copies of your own work and be able to reproduce it. And 3D printers these days can reproduce objects in plastic, PLA, or nylon, and some of them can even do polycarbonate, which is very rugged. So this concludes the demo that I have today on using stepper motors with the VEX construction system. Thank you very much.